Hi guys, so this is I guess an explanation to my best ability of number 23 on homework 2 in chapter 2. And so the question is asking us to prove that every group table is a Latin square. So we're going to begin our proof by briefly describing the definition of what it means to be a Latin square. So as you can see, a Latin square is such that each element of a group appears exactly once in each row and column. So after reading through the textbook a couple times and looking over my notes, I kind of assumed that this was going to be true. So I began this proof using a proof by contradiction and assuming that one row has two elements that are equal to each other, and then proving that this is going to be impossible. So you can do this in two different ways because you can either take the approach of using the rows or the columns. I took the approach of using the rows and then later explaining why this also applies to columns. So I said, let us call the row A and the first column B and the second column C such that AB is equal to AC. So if this is our first row A and this is our first column B and this is our second column C, we're trying to prove that it's impossible to have two entries, which is just two stars or two elements in G, such that these can't both be in the same row or column. So since we have it set up where AB is equal to AC, we're next going to use either left cancellation or left multiplying by A inverse to reduce it to B is equal to C. Now you could do the exact same thing where if instead of doing it in terms of the row A, you could pick the first column and say the entry in the first column in the first row and the entry of the first column in the second row can't be equal to each other. And if you did it that way, then instead of left canceling or left multiplying, you would right multiply by B inverse. So basically, this leads us to a contradiction because if B is equal to C, then the row A, composed, I guess, with the column B, would be equal to the row A composed with the column C. And this would be impossible to have two elements in one row or one column to be the same by the definition of the Latin square, which is what we already described above. So this is just kind of our concluding statement, staying by our proof by contradiction. It is not possible to have the same element repeated in one row or column.